ON19, P41, question 11. With reference to the photoelectric effect, state what is meant by work function energy. Oh, work function is what we call the phi. But of course, it's an energy. It's a measure of how much energy is needed. So how to say this one, I already say energy, right? So it is the minimum energy required to do what Think carefully. Minimum energy required for or to remove to remove an electron from the metal surface. So we can say from the surface. I'll say surface. Okay, so this one is 2 marks. Energy required to remove electron. This one is going to be 1 mark. Now the other mark can come from many places. One example is you talk about minimum energy. That's possible, 1 mark. Or you can say remove electron from surface. That could be 1 mark also. But you can get 2 so you choose which one you want. Okay, so this note, this work function energy is different for each element. Sodium, zinc, aluminium, every one of them have a different work function depending on their atomic structure, electron, and all those things. So just need to know it's different for each element. Okay, work function energy of a clean metal surface is 5.5 times 10 negative 19. So this one I'm going to write straight away. Oh, this is my phi. A EM radiation of wavelength. Ooh, when I see wavelength, I put lambda. Is incident on the metal surface, so it's shining on the surface. The metal is in a vacuum. Calculate the photon energy. What's a photon? Photon is referring to this electromagnetic radiation. So the photon packet come in. Okay, it's like a packet like that. And it has a wavelength of 280. So you want to calculate energy, right? Remember, E equals to HF. Or, say, miss, there's no frequency here. Only got wavelength. Don't forget electromagnetic wave. C equals to F lambda. So we can sub in the F and you will get Hc over lambda. That is the second equation you can use to calculate. So let's go and do that right now. So let's put in energy of the photon will be H, which is 6.63 times 10 negative 34. You can find this constant on the first page of your data formula sheet in every exam paper. C is what? Speed of light. 3 times 10 to the power of 8. Okay, so this one is moving at the speed of C. Divided by wavelength. So 280. Oh, be careful, nanometer. Nano means times 10 to the negative 9. So I do a quick check. This is meter. This is meter per second. This one is in joule second. Okay, all is in SI base units. I mean, they can be converted to SI base, but they are generally base units. Okay, so what is this value? This I will get 7.10 times 10 negative 19 joule. So I can write, I'm going to write 2 as F. Okay, so 7.1 times 10 negative 19. This one, the unit is in joule. I cannot see. Now, joule. So be careful, whether it's joule or EV, you must do conversion lah. So 1 mark for your final answer, 7.1. Ding! Another mark for substituting into the equation. So this one. If you knew this thing, this is the important one lah. Or this one lah. But you don't have F, you need to find lambda. So that's where we go. Okay, the next one. Calculate the maximum speed of the electrons emitted from the surface. How to find maximum speed of electron emitted? So we know work function. We know photon come in how much. So that means that means you have a metal here that has let's see. Let's color this metal gray color. Okay, in the metal there are many layers of electrons, but the electron that have the maximum energy will be the one closest to the surface, like this one, because if the work function is 5.5 5.5 times 10 negative 19. Okay, that means this fella only need 5.5, then escape now. I'm just gonna not write the whole thing out all the time. So 5.5 you can get out already. So if your incoming photon has an energy of 7.1 times 10 negative 19, E photon, what is the extra energy that will come out? Okay, so if you have deeper electrons, they will need more energy to come out lah, so they won't be as fast. But this guy near the surface, wow, come out got a big fastest energy because it is closer to the surface. Just 5.5, you can be out. So what is this vMAX? We're going to use an idea of energy conservation. So photon. Einstein's equation, E photon equals to work function plus the kinetic energy maximum. Okay, what comes in is provided. So this is provided. And the one that will have the fastest speed will be the one that just used the work function. So this is 5.5 used. And you have a KE that is remaining. So that is this one. Energy conservation. Okay, let's calculate. So photon will be 7.1 times 10 negative 19. Actually, let's rearrange a bit. Okay, rearrange. So E photon minus the work function energy equals to kinetic energy maximum. Oh, this one can write as half vMAX square. So we submit all the values we know. This one will be 7.1 photon energy minus the work function. Now, what's the work function? 5.5. And these are all times 10 negative 19. So this will be half mass of electron times the velocity of this electron. Wow, what is ME? ME is a constant that you can find on the first page of every past paper. So that will be 9.11 times 10 to the negative 31 kg. So you sub in inside there. You should find a vMAX of about 5.93 times 10 to the 5 meters per second. And I'm going to round it off to 2SF, 5.9 times 10 to the 5. Wow, means the fastest electron use up 5.5, escape the surface now. And then you have a lot of energy, which is about quite a lot, I don't know how much, but you'll be moving at the fastest speed. So you have other electrons inside there, they will also come to the surface, they'll need more energy, so more energy to reach the surface, and then whatever is left over, then they will come out on the surface. But their energy won't be so far, they won't have so much kinetic energy left over because they use a lot of energy just to come out. Then little bit left. Okay, so 3 marks for this one. Final answer is 1. Then 1 mark is if you plug in everything into the equation. 1 mark if you knew that you need to minus these two in this kind of form. Okay, that's the other mark. Or you show that you knew okay, you write the equation and then you minus, you get the answer. Also can. So 3 marks for this one. Okay, last part. Explain. Explain question. Explain why most of the electrons will have a speed lower than vMAX. Didn't we just draw the picture over here? This one is nearest to the surface, the minimum energy needed to escape. That's what we call work function ma. Work function is the minimum energy. So mean energy to escape. So 5.5 and it's out. So the rest you will need more energy. Maybe you will need 7.5 times 10 negative 19 to get out. What's left? 7.5 cannot even get out. Aiyo, some of them cannot even get out leh. Okay, 6.5 maybe. Let's say this fella that is deeper needs 7.0 to get out of the metal. What is left? This poor fella will only have a KE of 0.1 times 10 negative 19. Aiyo, so little energy left. Use all the energy. So we need to explain this idea why the vMAX is just going to use a work function. It's closest to the surface, so you just use work function, can get out already. That's the minimum energy. So let's write that down here. So we can say that the energy needed let's say let's change this. Let's say more energy than our work function, which is the minimum 5.5. More energy than the work function, which is 5.5 times 10 to negative 19 is needed to raise electron to the surface of metal. Okay, if you can talk about this idea, the idea of work function, that's a B1 mark. Okay, so just remember, minimum energy is the work function, and that minimum energy you come out now, you have the largest kinetic energy, largest energy left over. Everybody else all down there one, down here lah. Some might not even manage to get out in the end of the day. They might be stuck here. Some are so deep they won't even escape at all. They don't even have enough energy. Okay, so all these fellas are down there, but the minimum, this one. So everybody else will have lower energy already lor, because they use a lot of energy just to get to the surface. Now the final part of this question, part C, is where the question really gets interesting and challenges your thinking. So here you have a table. 4 marks! Look at these 4 on top of me. Oh my goodness. So electromagnetic radiation incident on metal surface may change in intensity or frequency. So either the intensity I is changing or frequency F. Complete the table by saying increase, decrease, or no change to describe the effects on what? Effects on maximum speed and rate of emission of electrons. Okay, so rate of emission of electrons is what we call, the rate, like dN dt. N is number of electrons, so dN dt is in 1 second how many electrons can come out. Maximum speed is what we know previously as Ke_max. Let's think through this very carefully. Number 1, reduce intensity at constant frequency. What does that tell you? What does reduce intensity mean? Now a lot of us will say, Miss, reduced intensity means less electrons, less photons. Yes, but be very careful. This is a warning sign for you. Intensity is not just number of electrons, okay? Intensity, you gotta remember, is a power per unit area. In other words, this is like energy lah. Energy over time. Okay, that's the power. So actually, there's an unofficial photoelectric equation that they never tell you in A levels, but actually there's one that looks like this. The intensity of emission depends on Planck's constant, H, times the number of electrons, okay, like HF, times number of electrons over a certain area times time. This is the true definition of intensity. Okay, so dN dt is this part lah. So HF is each electron. I'll put this here. Each photon. And a certain rate of them coming out over a certain area. So this equation is not in A levels, but somehow they will ask questions that relate to this. So if you knew this equation, you'll be able to think through it a little more carefully. So be careful. Intensity is energy per unit area per unit time. Okay, so intensity is energy per unit area per unit time. And that can be opened up into this equation, this unofficial equation for photoelectric effect, intensity of photoelectric effect. Now let's go through this very carefully. Now that you know this shortcut, let's see. Reduced intensity means what? It just means lower energy per unit area times time. That's just all it's telling you. Does that mean lesser photons? I don't know. Let's see. And constant frequency. So this is the frequency energy of each photon. So you can think of it this way. Maybe originally you have electrons inside there. Then the total energy has decreased. The total lower energy has decreased. What does that mean? You have photons coming in, and each of them have the same amount of energy, so maybe 2 eV, 2 eV, 2 eV, another one come in. So these are fixed. They are not going to change because the frequency is fixed. All locked already, cannot change. But somehow your total energy have to reduce, because the reduced intensity means a reduce of total energy. So that means the only thing that that can happen here is there should be less number of photons. So maybe this one don't have lah. This one don't have. So less number of photons coming in. So that means reduced intensity. Let's write that down. Okay, total energy decrease, but each photon got the same amount of energy. So that means there have to be less number of them. Instead of 3, only have 1. Reduce intensity. Okay, so that one, the very first thing they will tell us is this one lah. Rate of emission of electrons is lesser, decrease. Why? Because 1 photon can only rescue 1 electron. So 1 photon can only give energy to 1 electron. So now there are less number of photons already. So less electrons will come out. Hence, less electrons come out. So less number of photons. Hence, less number of electrons per unit time. Because 1 photon, 1 electron come out. How about maximum kinetic energy of electrons? What do you think? Is there a change? No, there's just less of them, but they still can come out at the same Ke. So this one depends on the E of photon, which is your 2 eV. That's not changing, so no change. Hey, why green color? No change. Now, if you want to use the equation we looked at just now to help think about this idea, you can shortcut it, okay, this equation. You say intensity is proportional to, what are the relevant things? Frequency and number of photons coming in. So, you could say that, oh, in this case, constant frequency. Constant. So, if your intensity reduce, what must change? Number of photons must reduce. Okay, this is the number of photons. That's how you can think of the equation for the first one. Okay, let me move that down so we have more space down here. Okay, now it's down here in the bottom. I'm just going to rub this part off. Can I even rub things off? Okay, now it's getting a computer lag. Yeah. So this is scenario number 1. Think of photons coming in, all these little hints. Oh man, this is such an important question. Okay, then number 2. What is changing now? Increase frequency. Ooh. Now number 2, frequency is increased, but intensity is constant. How to think of it? Okay, we draw our metal here with electrons inside. Frequency constant. That tells me, so increased frequency, but constant intensity. So constant intensity means, constant I means that the total energy is the same. So now each packet, each photon coming in, at first maybe it have 2 eV like the left side. Now increase to 4 eV. Whoa. So that means there must be a lesser number of photons coming in. Okay, so I write out here, each photon has more energy. Because increased frequency. Okay, that's number 1. So, but total energy is the same. How do you put that two together? Total energy is the same, but each photon has more energy. So that means there must be less number of photons coming in. Think of it this way, total energy is the same, but each photon has more energy. So that means there must be less of them. No? So now at first, okay, let's see. Maybe I will draw for you. Let's do this. Maybe there's 2 eV, 2 eV, 2 eV. Okay. Total energy is 8 eV. 6 eV. Sorry, I cannot maths. 2, 6 eV, let's say. very high energy electron. But now I want to increase them to 4 or to 3 eV. So if I change this to 3 eV, and I change it to 3 eV, oh, then this one cannot already though. Already 6 maximum total energy. So there's less number of photons. Is what I say by less number of photons. Because you have to keep the same energy in total because constant intensity. Intensity is like total energy in the area. Okay? So how do we think of this thing? Rate of emission of electrons also decrease. Because the same rule applies. 1 photon to 1 electron. Okay, so if you have lesser number photon, you have less electron to come out. Okay, so this one can rescue 1 electron, this one can rescue the electron. Okay, what next? Frequency. So each photon, more energy, more E. So electron will have more energy also. So maybe if they use up a little bit to go to the surface, then they'll have more energy when they come out. So this one also come out more energy. So the Ke max will be much higher, increase now. So you can say increases. Increases. Wow, this one, a lot of people, they didn't get this one. But this is how you can get 4 marks. Very carefully. They can split them into explain and state, but they decided to put in the table. So you need to know all this story. This is a very important one. Oh, my head is blocking some. So last thing, if you want to think of the equation for the case number 2 on the right side, how? Intensity is proportional to the frequency and number of photons. What is constant? Total energy. So this one locked already. Put in the box. We are not changing it. But they said the frequency of each photon is increased. Okay. So this one increase. That means the number of photons have to decrease to maintain a constant intensity. It's like a ratio thing lah. Okay. So for this particular case, this is what we can do to shortcut to think of what is happening when you are changing things. It's kind of hard if you don't have an equation to know for sure. Okay. So this is a very tricky question. A lot of people got this one wrong. Make sure you know how to think about this, case 1 and case 2. But that's all for this question. Make sure you know how to think of intensity and stuff, but I will see you in the next example video.